Right. So I'm basically for I'm arguing from the position that energy and kinetic energy are both anomalies. They're unseen anomalies, while gravity is an actual principle. Gravity, as such, is a first principle of physics. Um, there's nothing to say that just because there are anomalies in the universe that we should be illogical to our evolution. So that is my discrimination against conventional physics because the abuse of the experimentation, like the experimentation or the perversion of what subatomics are actually doing. I'm also arguing that in a particle accelerator or um, in any field, photons can interact. It's just like even if I have the light to my even if I have the light bulb to my head with the electric charge and the coil and everything like that and the magnetism and it's basically precipitating fire, but it's a light bulb. It's it's concealed. It has a capacitor. Um, if I shine a flame to the light bulb, it they reflect, they interact. Obviously, there was a distribution, just like a clear window, and we know that like that these windows and glasses and all these things, the way they make glue, that they have to really stretch out materials. They have to like really stretch out plastics and different chemistry, and they just keep stretching it and stretching it and stretching it as if it does have some elasticity, but yeah, it came from a hard object, or you could say, but those things don't really harden over time. I mean, like rubber. Um, Rubber, I guess, tends to harden over time, and it gets like cracks and things like that. And you could say that, well, it just gets cracks because it's made out of even less material. I mean, it's well, that's kind of a tough question because if you have like, like a marble, or if you have like a pebble and a diamond, like why is the diamond completely clear and why is the marble, um, why is the marble uh, opaque? And obviously, it's because there is a more spread out distribution of the subatomics in the diamond that makes it clear. Um, and then you could say that it's like frozen around the outside. I mean, that's kind of like a tough question. And then the marble, since it's opaque, it has less distribution of the subatomics, but it has more subatomics. And since it has more subatomics, you can't see through it. So chemistry is pretty tough. But that also brings me to Tyson made a good video about fire shield and understanding that when something enters atmosphere, um, enters atmosphere. Yeah, it does. It should change um, the correlation between air and space. Like air should really have a um, there really should be a disassociation with air and space. And I don't think that ether really does that. And I don't think that these anomaly equations do it any justice. Um, unless, I mean, because unless like particle the photoelectric effect is, I mean, these some of these things are kind of true when it is dealing with, like the blue sky. You could almost say, well, the blue sky, um, the blue sky is blue because there is a reflection from the sun, but the sun is still able to beam through the blue sky during the day because there's so much energy. but that energy is being reflected and it doesn't allow us to see back out. So we can stare at the sun, but obviously not if we were out in space because we wouldn't be caught in so much reflection. So it's just like the reflection from the sun is just so strong. That's why we can't see space. Um, so again, and that's a subatomic anomaly. So I am saying, and then also just dealing with the fact, well, um, if you learn about gravity, you could say, well, um, yeah, there really has to be these subatomic laws. Like there can't just be principles here on Earth. Like there are things that we don't understand. Like how did this spherical moon uh, come out of the spherical Earth, and how did the spherical, sun come into superposition? And you'd have to like understand these things and say, well, yeah, like there is an anomaly there. So I mean, if you did have an infinity value on the universe, you could even say, well, I'm going to put a value on the infinity. I'm going to give infinity a value in this equation. Since I don't know whether or not it is infinity, I'll just go with it is. I mean, it's more logical to say, well, yeah, it's infinite, or at least it has infinite value to say that space is infinite because yeah, it's just never going to be figured out by Neanderthals and hominids. It's just not going to be. So, with that understanding, you learn that it's an anomaly. Something like gravity was just it was just a reciprocation of the universe, and you can see it. You can just see it clear as day that it really is apparent in every way. But and energy and kinetic energy will never be just perfectly out there for anybody to see. Um, like it'll never be fully testable, and but it's obvious that gravity is never fully testable. It's just such a clear understanding. It's just such a coherent way to articulate what's happening. But again, with the fire shield and what Tyson was talking about, you'll have more electricity and more static. I shouldn't say more, but a more spread out um, distribution of the electric universe out in space. Just like the diamond, you can see through space because it's spread out, and the subatomic is spread out, and so it's more electrical, it's more static in the sense that there is less hydrogen bonding. Now the hydrogen bonding gets stronger and stronger the more you get closer to Earth because of gravity, and that's an obvious that's an obvious notation, or that's an obvious. I mean, you could say that's well, I don't know how to put that, but like if you look at the anomaly of the kinetic universe and say, well, there's a three body problem with the sun, the moon, and the earth, and you say, well, that's obviously how gravity is happening, but how do you see gravity in action? Well, you could say that the hydrogen the hydrogen bonding is getting stronger and stronger the closer you get to Earth. So the closer you get to Earth, the less static discharge that there actually is, the less electricity, the less electrical universe you actually accelerate through. So you actually have less and less momentum. Obviously, you could say that you have the most momentum. I mean, you could maybe say that you have the most momentum in space just because you're held by less subatomics. But when you enter into Earth's atmosphere, you're going to be not accelerated, but yeah, jerked by these subatomics, and so there's that collision. Now that collision will never be that again to go to E equals mc squared. That collision will never take place at any other like at any other sequence and other than a one-dimensional plane. There's only a one-dimensional field in space, but obviously there is a mechanism in space. Obviously there is gravity in space, but there's only one dimension that's ever happening. Um, so it's still perverted to say that a different um, gravitational distribution of the electric universe will allow you to see or travel faster through space. Like there can't be, there's no logical way to, um, there's no logical way to think about a vacuum. It's only, it's only something that is miraculous. It's only something that wouldn't be understood. It could never be understood logically. It could never be understood rationally. Something like a vacuum or warping or a wormhole and these types of things. And these are perversions that have happened in science, or at least they're claiming that these things happen. Um, but there can be like a different reflection or refraction or something like that. But I mean, out in space, you'd only see that. You'd only see a refracting. You'd only see a refracting take place if like two galaxies were colliding or something. Anyway, but so I mean, I'm just saying, you know, it's not like they're going to be able to like take pictures of a black hole swallowing, you know, another black hole. It's insane to think about that stuff. But again, back to these like subatomic particles. So there's more and more subatomics are caught in a linear gravitational field of Earth. So the closer and closer you get to Earth, the more you're colliding, like the more a rock or a pebble or a diamond is colliding. Like when it becomes a meteorite and it starts catching fire and going through the atmosphere, coming closer and closer to the ground, that's when it's catching fire, and it's catching um, fire because there are more subatomics. Okay, and so there is less and less electricity. Like there is less and less electricity. There is less and less propulsion. There is less and less exhaustion. Um, that's taking place, and there is more work. There is more labor that is happening. Um, you could say, and then it goes further and further down, and then and then it like if it's really small, I mean, if it's a really small meteorite and it's not like a huge fucking asteroid and it's just a little meteorite, it'll essentially lose its fire shield. Okay, because when it had a fire shield, that's when it was making a jump from very little particles or a very huge distribution or a very huge spread out um, distribution of particles, but then it's like hitting, well, all those particles are shrunk. Or I said like it could have been to like the fifth power. So all of a sudden, you know, you're hitting everything you were just hitting, but to the fifth power, and then that's like your that's how many photons you're hitting at the same speed. So you're not accelerating, but you're hitting more subatomics, and then there is a transfer. And then you can understand a transformation would happen because the closer and closer you get to Earth, you get oxygen and things like that. Like you go from hydrogen, helium, and then you get oxygen, and that's when that's when the meteorite could start cooling down, and it'll actually lose. I mean, so it completely loses its fire shield. And if it's not like a huge asteroid, then it'll completely lose all. It looks like it'll lose like all of its fire. Again, so but that's like a real transformation, and that's like a real anomaly of how that happens and how that works. But it includes gravity. I mean, it realizes gravity, just the fire shoot. Um, and then yeah, so I mean, and so yeah, I just you know, and then like with the particle accelerators, I'm just saying there is an obvious colliding. There's an obvious interaction with light. Okay, it's more light than it is photons. A photon is kind of like A photon is kind of like a light particle. Like you could say, well, energy is kind of like energy is kind of like a bank, or kinetic energy is kind of like a bank, and like bank accounting, like like financial accounting or something. Well, I'm just saying, light is light is more like a continuous distribution of photons than actual little particles, little bits of photons. Okay. Again, I mean, and it's an anomaly because when you look at the solar eclipse through reflective, when you look at the solar eclipse through reflective lensing, you only see the sun's corona around the moon, and that's relativity. And when you look at the solar eclipse with your naked eye, you see the moon, and it's a lot smaller than the sun. And anybody can test that, and it'll be true because reflective lensing gives you um, reflective lensing essentially spreads out the amount of. You could say that it essentially gives you, yeah, it gives you a mirror image of what you would see if you spread out the subatomics. Like I was saying, out in space, the subatomics have to be spread out. Because obviously it wouldn't shrink the subatomics. I mean, that's essentially what a refractor telescope does. It's supposed to shrink. It's supposed to do the opposite. Reflector telescopes, they spread the subatomics, so they make closer objects look huge. Um, they make visible objects look huge, and then refractor telescopes, they make closer objects maybe more defined. But again, like how much could you shrink? Like how much refraction you would need to be able to shrink the moon compared to the sun over like an even distribution of subatomics, or like a constant distribution of subatomics. You'd have to have so much refraction, but then all that refraction would cover up like any remaining like enough remaining refraction to actually make the sun look any bigger. So refractor telescopes, they just really make things more defined, I would say. And and they're supposedly like harder to work on. And reflector telescopes, they just make closer things look way bigger. That's why NASA's that's why NASA's telescopes are reflector telescopes, because they want to make visible objects look bigger. So, and then yeah, just in a particle accelerator, um, there's got to be light. I mean, there's got to be subatomics colliding. It's just obvious because yes, if I put the flame, if I put the flame to the light, if I put the flame to the light bulb, I can't see the flame anymore. So the flame becomes transparent. If I put the flame um, in a shadow, then yes, I can see the flame. So there's obviously interaction between light. Light can interact. That's why I didn't like how light is particles, but I also don't think that light should be rays. I think light should be an actual, uh, like light should have, I mean, just describing the fire shield, how um, light is a distribution of subatomics, because like when I light the lighter, there's oil in there, and the oil is pushing up, and there's a spark, and that spark has an interaction with the oil, and then that's how it creates the flame. Or it's like there is a generator that is charging you know, this electrical output, and that light bulb has the coil and the magnetism to be able to interact with, and that's what allows it to burn. So the light bulb is burning, the lighter is burning. I was even saying like last night that the sun could be burning because you could have the sun with a core, like a solid core. I have heard, I think that, oh, there might, like, the sun might have a solid core and not just like it might not just be like a flaming molten core. Like it might actually be a solid. Like it might actually be the opposite of the Earth. And so you could just say, well, yeah, that's because there is a fire shield. Like it got caught in the orbit of the galaxy, and it started to have a fire. It started to develop a fire shield, and then when that fire shield collected enough energy um, from other meteorites and all that stuff, then it was like it actually caught on fire. Well, that's a tough argument, but again, sort of like an unknown, not necessary, not applicable, an anomaly. But yeah, I'm just saying, in terms of the subatomics, if you have less, if you have more, a more spread out distribution of subatomics, that like subatomic bits, then you will have more electricity and static electricity because they have to, in order for the subatomics to connect, they have to be connected by that charge effect, and that charge effect has to be distributed out all over the place. So it's like a universal um, connection or whatever through these charges. But then when you get closer, but then when you get caught in gravity, then that's when you hit. That's when the boat just capsizes because you have your inverse. You have an inverse. You have to follow the inverse law there, and your subatomics are going to be more condensed. So it's not that you're actually. It's not that the. It's not. You could say that you're not growing in proportion. I guess you could say both. Like there's the proportion, the amount of subatomics is growing, but essentially you're also hitting more matter that was already in the universe. So that's why it would follow the inverse square law, because you could essentially say, well, it's not just subatomics to the fifth power, it's subatomics to the negative fifth power, because you don't actually collide with you're colliding with less subatomics because there's more molecular property that you're hitting when you get into a gravitational field such as an atmosphere, and you start being sucked in and you start hitting gravity more and more and more and more. um, so anyway, I think that makes sense. um, yeah. All right. I would also say that in terms of these anomalies, well, what I would call anomalies, energy and kinetic energy, these are subatomics happening, and they're happening. They're all. I mean, there's only one dimension, but there is one dimension with many one-time events that are happening, and I think that's just a good way to look at it. It's a good way for determinism. There's just one dimension with many one-time events happening. So nothing is repeating in terms of like what can you repeat in the universe? I mean, nothing is really repeatable. It's only like these psychological routines and words and uh, mistakes, things like that you can repeat, but those aren't concrete things that are actually happening. The concrete subatomics that are causing these things to happen are all one-time events. They're just all right. Anyway, all right. So here you obviously have on the left. Here on the left, you obviously have your fire shield. You can see. It's funny. You can. I mean, it's a white board. You can't even see the flame like about right here. You can't even see the flame, but the flame, it's the same flame, you'd imagine. Okay, so it's the same flame, but it's a white board, or it's a white piece of really uh, thick cardboard, and you can't see the flame. But then when it starts to was it diox? I don't know, dioxide or whatever. Oxide, yeah, when the oxidation process happens, and that's when you see the carbon imprint of the flame. So, all right, so you see the flame and everything, but I'm just, Jesus fucking Christ. I'm just saying there is a difference between these two backgrounds. Obviously, one background. Well, you could even say the one background is covered in plastic. Now, plastic doesn't seem like a really materialistic object. It seems like it would have less particles, um, but that just depends how the plastic is made. Is the plastic clear, is the plastic solid, or more solid? Like I mean, more opaque. So how much applied subatomics is actually in that plastic? Now, I would say that would be a heavily applied. You could say, well, you could say there's a mixture because it does seem like if it would burn, then it would have some really dense subatomics. Like, well, I guess plastics would be really dense subatomics just because like they'd have to have so many chemicals where something like wood would have a more structured subatomic level, but it wouldn't have that many. Um, obviously, wood is biodegradable, so it has to have less subatomics. I would also say that um, that's what acts like a shield. That's why if something hits something at an uneven rate, I don't really know how to correlate that, but that's where I'm going with that, and I'm just gonna stop there. 'Cause I don't really know what I'm saying. I should know what I'm saying, but the anomaly is too strong. The forces are taking me under. But this is really interesting because I just wanted to get into this one. Uh, you can see that the water. I was just saying, I'm having a lot of OBS problems. Yeah, I was just saying that. Okay, so the water is floating towards the balloon. The water's. It looks like the balloon is acting as a gravitational force. Um, and I would say that because yes, the balloon has very high uh, energy. It has very high energetics. It has very high electricity because the subatomics are so spread out just between hydrogen and helium. Uh, just between helium, there's nothing really going on except for a lot of static force within a elastic balloon. Um, so you could understand, and also H2O is a very like there's oxidized particles, bits of matter in the rubber band balloon, and then so you could see how it's an anomaly, how it's how could that percolate like in the universe, but yeah, it makes sense if you think of it subatomically because there's more um, there's more molecules. Okay, there's more molecules, or there's more subatomics in water than there is in the balloon, but also the balloon has subatomics itself, and the balloon carries the largest amount of subatomics. You could say that helium is the core of the balloon, and the balloon is the crust of the entire object. So the crust of the balloon, the rubber acts as like a distribution service for the water, and that's why the rubber actually pulls in. It actually pulls in I should say the balloon actually pulls in the water when you're holding it up like that. I was like, that's kind of my explanation. It's just there is, and it gets closer and closer to the balloon. The closer you get, the closer the balloon gets to the water, the closer it gets. Um, and I would just say that that's because there's more static electric forces happening within the balloon than the water, and the rubber balloon is acting like a medium. Since this is a very low particle, these are very, well, I should say helium is a gas and water is a liquid. So those have very little subatomic particles, obviously gas would have less subatomic. I mean, it makes sense. It's logical to say that gas would have less subatomic particles than liquids, and then solids would have the most subatomic particles. But that means that there is less electricity happening with those objects. Obviously, it makes that makes gravity have a lot of sense, but it's still the fact still remains that subatomics are an anomaly. Like they are, like, where do they come from? They're miraculous in a way. That's what I'm saying. They are an anomaly, so they should have, they technically, in my opinion, they should have, um like a word, like energy or kinetic energy, obviously. But again, like, these things should not be perverted. They should be understood. STEM should be like heard loud and clear, but it's not. It's not. And people are playing around with that, and I don't know why. It seems like it's been hijacked. Um, it seems like energy was just hijacked. So I think that's